substance abuse in early 82 and studying morphine dependence and withdrawal, because we believe that all psychostimulants are stress. And what we found at that time in early 80s, that morphine dependent rats showed a decrease in blood-brain barrier permeability in certain areas. We still do not any clear answer, but I'm very happy to see that some areas have shrinkage and some area in human cases were swollen. Well, but this is still, we do not understand. But at that time, we found distinct increase in the permeability of the blood-brain barrier in different areas after morphine withdrawal. We have no idea at all. So we kept this data for 20 years to understand that what is that. But anyway, so the point is that our interest in psychostimulants is very old, and then I came to NCTR to understand because they have this pioneer work on methamphetamine abuse and toxicity. So that's why I went to FDA and I worked with Sai Valley, and then because you know, if you publish some works from purely Indian laboratories, many people will not believe even they are true. So that was one of the reasons I went to a world-class lab and worked with Sai Valley and found the same thing, then we published. So, and after that, to further confirm, I went to NIDA, worked with Dr. Kiatkin on methamphetamine and other substances, including cocaine. So we were encouraged that whatever we thought earlier, 25 years ago, is still right. And so therefore, we, in a long series of a study, we are studying cocaine because there are lots of investigation on cocaine in animal model. It increases heat shock protein, it increases hypothermia, and so many things. But nobody has studied blood-brain barrier permeability. So since our interest that we believe that every neurotoxicity has something to do with the opening of the blood-brain barrier or edema formation, so this is the background. And obviously, since we have interest in nanoparticles, I will come back later to you. We try to see that whether these effects are also influenced by nanoparticles. She sends greetings from Banaras Hindu University, and I should give one line caution that Hindu does not represent any religion. In Sanskrit, it means universal. So this is a universal university, means everyone is welcome. Cerium. Ceria, there are different names, and when we come to the nanoparticles, it is still controversial, and I believe that the field will be controversial for certain time. So there are some reports that Ceria can be neuroprotective. But there are other reports that this nanoparticle can be neurotoxic too. This is commonly used in different kinds of human applications, including inside the oven, some cosmetics, jewelry cleaning, and many other things. This area is used. But nobody has studied its neurotoxic effect. I can show you that this paper published in 2006, I guess, that cerium and yttrium oxide are neuroprotective. But on the other hand, United States Environmental Protection Agency in 2009 described in detail that there is also toxicological components in it. But unfortunately, not very much written about neurotoxicology. They have liver, kidney, and other organs. So therefore, it still needs worthwhile to study. We have in animal models, rats reported that propane produces regional changes in the blood-brain barrier permeability because it also increases heat shock protein and many other factors. Animal models are very difficult to produce because when we are taking either rats or mice, their lifespan is maximum 2 years, about, some even could be shorter, but humans are 70 average, and therefore we do not know that if we are exposing them for 4 hours, how much time in real sense it covers. So it is acute or chronic, we are not clear to decide. But our animal models were 4 hours, and the dosage is also another problem. So we have used certain doses to be maybe someone it is high, but we try to study the changes. Some recent studies telling that cocaine is toxic to and induces oxidative stress. This is a very good review. Psychostimulants are used in neuroinflammation, and it also mentions, I mentioned cocaine. And then, so these are telling recently in 2012 that cocaine may be neurotoxic. So then the point is that the combination of Syria and cocaine. Here, in order to study two things, that whether the Syria oxide or Cerium oxide is neuroprotective or making neurotoxicity, and whether it is size dependent. So she chose two sizes, 25 or 50 nanometer for the range, and they were given 25 milligram or 50 milligram per 1800 mg, and the cocaine they used 40 milligram per kilogram. Of course, our parameters are blood-brain barrier permeability, brain edema, and neurodamages. This is the book we produced some time ago, the psychostimulants induced neurotoxicity. So our main interest is that we wanted to highlight neurotoxicological aspects of psychostimulants. Now the data here. So this is control, and we measured elevation of Cerium and also cocaine in the blood plasma. And here is control Cerium 25 milligram elevated, 50 milligram in room, and these are smaller sizes, and these are large size Cerium and administered. Of course, the increase in plasma, but not that. So could be this, the time span that we have used. This is elevation in plasma is also size. Cocaine 40 milligram. You can see still the cocaine is high in plasma. When it is combined with 25 nanometer size of Syria and 25 milligram, you can see the increase in. Here is the Cerium and also the cocaine. With double dose and the same size, the increase is lower. But with higher dose of large size Cerium, you can see that this increase in cocaine level in plasma is not that much high. We do not understand this at all. Here, we can see that this is radioiodine leakage here, and 25 milligram dose of cocaine and Syria here, less increase cocaine itself, but a combination here. 40 milligram cocaine alone and combination of Syria 25 and 50 milligram, the higher, and the larger size will make less increase in the permeability. So the point is that nanoparticles, there is a surveyed cocaine induced breakdown, but that depending on their size and permeability. Previously, we have published results from both NIDA and also FDA that methamphetamine in different doses, either 40 milligram per kilogram intraperitoneally in FDA and 9 milligram SC and subcutaneously in NIDA, also increases blood-brain barrier permeability and edema. So cocaine is also doing the same, but the main interest is that if it is combined with nanoparticles of the smaller size, the increase in water content is higher than if it is combined with large size of nanoparticles here. So therefore, we are looking other independent evidences of increased brain water content after psychostimulants abuse, and in these consequences, I think that your human data is very important to us. Neuronal changes are normally following the same thing. So this is cocaine alone and small size nanoparticles and larger size nanoparticles. So the neuronal damages are highest and also depending on the dose when the small size was used. This is an example of cortical changes. It's cocaine alone and then it is combined with Syria, and what we can see that sponginess and edema is increased. Neuronal damages are much more there, and this shows probably shrinking, and in some cases it is expansion, and this is the pathological image that we get, and that's why I asked the question, because in some cases, thickness is reduced and some area is expanded. So on the basis of these preliminary observations, we can point it out that cerium oxide enhanced cocaine-induced neurotoxicity, and this effect is size related, and we do not know that why larger size is less toxic, but there are different theories available in the literature. Probably has to do something with many other factors and might be in production of oxidative stress. So our next stage is that we are measuring oxidative stress in these identical regions in different brain areas. And of course, the one thing is that its penetration under certain time period, and if higher plasma levels are there, probably they could be more damaging to the brain or blood-brain barrier permeability. But these things we cannot say at the moment for sure. And this is why research work we are doing in our lab, as you can see, very well known caffeine. And this is Anka, this is my colleague Dr. Anupre. He is also interested in morphine induced analgesia, and these are other colleagues from the work at the Institute of National Institute of Technology. If you'd like to show this Ganges and hearts from Varanasi, everyone is welcome. And I would like to have your suggestions on this presentation. Thank you very much. Yes.
So Harry, is the general idea, do you think, that the nanoparticles are in some way opening up the blood-brain barrier and allowing the cocaine to cause more dramatic effects, or what are you thinking about the model here?
We believe so, but we have no clear proof unless we do electron microscopy or other areas. But our hypothesis is that nanoparticles could induce breakdown of the barrier and then allowing more materials to go in. And then that's why the neurotoxicity is.
So, I mean, you could look maybe at other markers that would maybe not normally be in the brain to see whether or not they're maybe enhanced by this effect, so you can get additional indicators that the blood-brain barrier is being damaged in some way.
Yeah, the other markers that we use, the endogenous leakage of albumin. So it is not in the brain. And when we use these type of combination, I'm not showing those investigations, we can see really that albumin is entering into the brain, and it is more than, it's very large.
It's going up.
It's going up, yeah. Both in the neuropage and depending on the survival period, also it can stay in the neurons, and according to many other theories from neuropathology, if neurons uptake albumin, it probably could be staying high. Yes, sir.
Could you, this may be outside, but titanium dioxide, have you looked at that? Because it's a huge component for sunblock. And I was wondering whether or not anyone has actually looked to see if cocaine and titanium dioxide was going to actually have a synergistic negative effect.
No, this is a quite good question. Actually, we are using titanium dioxide nanowires with Dr. Ryan Tian at the University of Arkansas in Fayetteville. And then we load drug with that, and nanowire drug delivery is one of the important projects for us. So therefore, we started looking titanium dioxide neurotoxicity. And in some of the experiments, we have not done in this way, but in spinal cord injury, sometimes even we apply this titanium dioxide nanowires over the spinal cord, or even titanium powder we have injected. So far in our hand, up to 12 hours, this is the most innocuous nanomaterial. And there is also a paper published in Germany in Acta Neuropathology. We believe this paper is very important. They have used in mice even 200 milligram per kilogram body weight. It's a very high dose, and they can see that even liver and kidney toxicity was not there. So they compare different nanoparticles, and they also feel that titanium is most innocuous. So, but anyway, any nanomaterial can produce neurotoxicity. This is our next target, to also have a combination of this. But in this model, we have not used titanium so far. No. Patnaik.